Right, guys, we're gonna look at corrections, exercise 3B. It's on page 64. Okay, so we had to do number 4 there. We can see the power there is 6 to the power x. Okay, so the idea is we need to convert the right hand side to have the same base. We've got 1 over 6 at the moment, so if I just write the left hand side as it is, the right hand side, for us to manipulate this into being a power with the same base, we can take this 6 to the top. Once we take this 6 to the top, it becomes 6 to the minus 1. Okay, we've learned that from the negative exponents. Once we have that, we are home and dry. All we need to do is to drop the bases because we've got the same exponents. Okay, bases are the same, we drop them, we have x is equals to -1 is our final answer there. Okay, question 2, had to do number 8. Okay, number 8, same thing. We've got the power here with 4. We've got 1 over 16 on the right hand side. So we keep the left the same. Just one extra step here. This will be 4 to the power 2. Okay. So then once we've done that, we can convert this and take this up to the top there to manipulate it so that it has the same base as 4 to the power x. It will be 4 to the minus 2, of course. Why? Because when the exponent crosses the border of the divide line, either way, whether it's coming from top to the bottom or it's going from bottom to top, so numerator to denominator or denominator to numerator, what happens is that exponent changes its sign. In this case, it was positive, it's going to be negative. So that will mean x is minus 2. Right, in the previous examples, we've had to look at the right hand side. It looks like here we'll have to manipulate the left hand side. Okay. So what we can do then is we can convert the right hand side into exponential form, which will be 2 to the power 2. And then what do we have to do this side to have 2 as a base of a power? What we have to do, we can change this to be 2 over 1. We know we'll change the exponent, it will be negative. Yeah, it's basically a reciprocal. Once we swap it around from numerator to denominator, we swap both, the power is going to be negative x. This is of course the same if you remove the 1 as in the denominator. Okay, it's the same thing. So what we'll have then is we've got all of a sudden 2 minus x is equals to 2 to the power 2. What do we have there? We've got the same bases again. So that will mean x is equals to -2. Because this is negative, x is equals to 2. We divide both sides by -1. That's why we end up with x is equals to -2. Okay, moving to question number 16. Question number 16, we'll do exactly the same thing there. We'll take 9 to the top and 1 in the bottom. We'll end up with the exponent that is negative. We don't need to change the right hand side. We can leave it as it is. It's basically 9 to the power 1. So then we will have negative x is equals to 1, which in turn means x is -1. That's number right. Number 20 is as follows. So what we have to do here, we need to always be smart here. What we try to do is, just when we solve for x, we need to solve for this power. We need to separate this power from this coefficient, whatever this coefficient is doing here. Okay, so what we'll do is we'll multiply that equation by 8 because we're trying to get rid of this here. We're trying to get rid of 1 over 8. 8 is in the denominator, so we'll multiply everything by 8. So whatever we do on the left hand side, we need to do on the right hand side. So what will be left is 2 to the power 2x is equals to 8. Multiply both sides by 8. Okay, 1 times 8 is 8. When I multiply the left hand side by that, I'm left with 2 to the power x. Okay, So next, I manipulate the right hand side. It's 2 to the power 3. We know that 2 to the 2x. And I've got the same bases, guys. Whenever I have the same bases, I drop the bases. So I'm left with 2x is equals to 3. Then I'm left with x must be 3 over 2.